Dear friends, welcome you all for today's class. Today we are going to discuss about how to increase mean temperature and overall performance of thermal power plant using Rankine cycle by using combined features of reheat and regenerative cycle. In our previous classes, we have seen that by using reheat or regenerative cycle, individually we can enhance mean temperature of heat addition of the Rankine cycle. Every cycle, whether it is reheat cycle, regenerative cycle, both have their advantages and disadvantages. Both have some features which are advantageous, some features are which are not favorable. So by using combined effect of the reheat and regenerative cycle, we can optimize performance of thermal power plant based on Rankine cycle. So here, because in most of the thermal power plant in modern days, whether these are based on nuclear power plant, based on the coal-based thermal power plant, or using any kind of the fuel, but working fluid, if it is water and in the steam, then it is based on the combined cycle of the reheat and regenerative cycle. In reheat cycle, we have seen that total steam we have to take back from the turbine. Instead of the condenser, we bypass it from the boiler. So it is a complex process. It is a costly, lot of investment required, and a regenerative cycle is comparatively less costly and less complex. But in regenerative cycle, work because we take back partial some quantity of steam from the turbine. So overall steam that expand in turbine, so work output will reduce when we use a regenerative cycle. So work output will reduce. That is a drawback. So we use both reheat and regenerative cycle today, and see how we represent it on schematic diagram, how how it work, and we show it on the TF diagram to make it convenient to understand you. So first we discuss it on process chart, and then we discuss it on the TF diagram, and then we will calculate energy mass balance equation, thermal efficiencies, everything we calculate by using TF diagram and flow chart. So let us start to draw a schematic of the combined cycle of reheat and regenerative. So this is a combined cycle of reheat and regenerative Rankine cycle that is nowadays in thermal power plants. All modern thermal power plants use this regenerative and reheat cycle slightly in different form, but the basic principle is same. So you first see different component. This is a boiler, this is a high pressure turbine, low pressure turbine, generator, condenser, heater 1, heater 2, heater 3, and pump 1, pump 2, pump 3, 4 pump. So there are three regenerator, reheat, feedwater heater, and there are four pumps. And so let us see how it works. So starting from the boiler will supply high temperature, means the superheated steam from the boiler will supply to the high pressure turbine. Here turbine steam enter here at H1 condition, H1 enthalpy, and up to state 2 at lower temperature, and because as it will expand through the turbine blades, pressure and temperature both will drop at state 2. At state 2 enthalpy will be S2, and M1 quantity means here we have taken 1 kg of steam circulating in the circuit just but in actual cases for very high power 500 megawatt turbines and more, will huge quantity of steam will circulate. But here for understanding, we only taking 1 kg of steam is going, and M1 kg of steam is bypassed. This is very small quantity of steam bypassed to the heater, feed water heater 1, and so remaining quantity will be 1 minus M1 will expand from state 2 to state 3. At state 3, total steam is taken back for reheating purpose at this pressure P3, and it will be reheated up to the higher temperature, initial temperature or below initial maximum temperature. It is reheated in the boiler by use of exhaust gases in boiler furnace, and then bypass it, then pass it to the low pressure turbine where it is expand from state 4 to state 5, and at state 5 again M2 quantity of steam is bypassed to heater 2. So remaining will be 1 minus M1 minus M2 will expand from state 5 to state 6. At state 6 M3 quantity of steam is again taken back for the heater, feedwater heater 3, and so remaining quantity here 1 minus M1 minus M2 minus M3 will be expanded from state 6 to state 7 and going to the condenser. Here in condensation process, due to cold water is supplied continuously from the river, stream or canal, so it will condensate in condenser. So condensate taken back by the pump 1 from state 8 to state 9. So it will pumped back to the heater number 3 here. 1 minus M1 minus M2 minus M3 quantity of the water will mixed with M3 quantity of the steam. So remaining quantity, so quantity will increase. 1 minus M1 minus M2 will be pumped again from the pump number 2 to the heater number 2. Here again M2 quantity of steam will mix with 1 minus M1 minus M2. So quantity will become 1 minus M1. So 1 minus M1 quantity of water will be pumped by pump number 3. So here again M1 quantity of the steam will mix with 1 minus M1 quantity of feed water. So final quantity of water will become 1 kg. So in this circuit 1 kg will again supply to the boiler. So this is a process in which reheat and regenerative cycle. Here this is a regeneration and this one is a reheat. Now this process we will see on the TF diagram to understand how we can correlate both processes on TF diagram with this flow chart. Starting from state 1, state 1 will expand up to state 2. This is state 2. Here quantity M1 is taken. Quantity M1 is taken as state 1, and from 2, you see from 2 to 3. From 2 to 3, 1 minus M1 will flow. This is a 3. So at 3 it is a reheated. It is reheated. 3 to 4. And from 4 to 5 it will expand. From 4 to 5 it will expand. At 5 M2 quantity is taken. So at 5 M2 quantity is taken to the regenerator, and from 5 to 6 it will expand in turbine. If we do 5 to 6 it will expand in turbine, and at 6 we again see at 6 M3 quantity is taken to the reheater M3, and from 6 it will be finally reaching to the condenser. So here 6 to 7, now it reaches to the condenser, and here from condenser condensation process will start 1 minus M1 minus M2 minus M3. So now it is complete. Now we have to draw pumping process from 8 to 9. From 8 to 9 pumping will be there, so I will show it by another color. 8 to 9 pumping process will be there. 8 to 9 and 9 to 10, because 9 to 10 you see 8 to 9 pumping, 9 to 10 this will be 9, this will be 9 and 9, 9 to 10, 10 to 11, 11 to 12. So 9 to 10, 9 to 10 is a process in which M3 quantity will mix. So this will be 10, and 10 to 11 is again pumping process. You can see 10 to 11 is again pumping process, pumping 2. So 10 to 11 is a pumping process, 10 to 11 and 11 to 12. 11 to 12. And here you see 11 to 12, M2 quantity is again mixing. So here 1 minus M1 will reach here 12 to 13, 12 to 13 and 13 to 8 to 9, 9 to 10, 10 to 11, 11 to 12, 12 to 13. 13 to 14, 14 and 14 to 15 is again pumping process. 14 to 15 is again pumping process, 15. So this is a complete. This now complete. So there you can see there are 4 pumping. pumping 1 8 to 9, pumping 2 10 to 11, pumping 3 12 to 13, pumping 4 14 to 15. Here you see pumping 8 to 9 is pumping, 10 to 11 is pumping, 12 to 13 is pumping process, 14 to 15 is a pumping process. Here you can see the same, you can see, and quantity is correspondingly as you move up, more and more quantity, because here you can see here pump 1 will take only 1 minus m1 minus m2 minus m3 kg of steam, and pump 2 will take m3 is adding 1 minus m1 minus m2, pump 3 will take 1 minus m1, pump 4 will take only 1 kg. So this is a cyclic process on the TF diagram. Same process you can also represent on the HF diagram, but it is more convenient. So now again one see 15 to 1. 15 to 1 is a heat addition process in boiler. You see 15 to 1 from here to here. You can see 15, you can start here or here. 15 to 1 is a heat addition process. Due to regeneration and reheat, heat addition process is upgraded from 15 to 1. Suppose there is no any reheat and regeneration. Heat addition process will start from state 8 to 1. So higher you can see due to incorporation of the regenerative heater and reheater in reheating in boiler, heat addition process from boiler is at higher temperature. Means before adding heat in the boiler, we heat the feed water up to more than 100 degrees centigrade, because when pressure is increases, boiling point of water is also increased. So there is a facility that we can heat water up to 120 130 degrees centigrade at saturated liquid state, and then we heat the water so that maximum of amount of heat addition in boiler is utilized for the increasing superheating of the steam. That is a advantage of using reheater and regenerator. In absence of reheat or regenerator, the heat addition process will start from at very low temperature. But due to incorporation of regenerator and reheater, heat addition process will start from 15 to 1. At this point, temperature of the saturated liquid will be around more than 120 degrees centigrade at very high pressure, because this cycle works at around very high pressure, means 20 megapascal, 30 megapascal, means up to 200 times. 20 megapascal means 200 times of the atmospheric pressure. So this huge pressure, so we can increase temperature. So now let us start calculating turbine work and net work and heat addition, all these things, energy balance equations. So first we write, I think it is better to write energy balance equation of heater 1, heater 2 and heater 3. Always start energy balance equation from heater 1, otherwise because you will find a less number of unknown quantity. Only M1 is unknown. If you start from here, you will find 3 quantities are unknown. So start always from heater 1. So writing energy and mass balance for heater 1, because this analysis is very important in sense that GATE questions and IES you will find the block diagram is given, and in table you will find enthalpies are given. You have to calculate mass of the M1, M2 and M3. Or everything is given, some missing enthalpy is given. You have to find out missing enthalpy by given data. If you know how to use energy balance and mass balance equation, you can easily find all these things. So let us start energy balance equation for heater number 1. So apply, you can see that at this heater there are 2 streams are incoming and 1 is outgoing. So you can see 14 is outgoing, and here 13 and 2, at state 2 steam is incoming. So S2 stated to S2 into M1 and plus 1 minus M1 into enthalpy at this point is 14, H14 equal to H13 equal to H14, and steam outgoing from this heater. So now you can calculate M1 equal to, by using this equation, M1 equal to H14 minus H13 upon H2 minus H13. So this is a very simplest way of finding mass M1. M1 quantity of steam that is taken from the turbine at state 2 for regenerator 1, or you can say feedwater heater 1, can calculate by using this mass energy balance equation. Once you get M1, then you can find out M2 in terms of M1, then you can find out M3 in terms of M1 and M2. Now we write energy balance equation for the heater number 2. So now write energy balance equation for heater number 2. For heater number 2, you see again apply incoming masses and outgoing masses for heater number 2. M2 into H5, because at state 5 M2 is taken, M2 into H5 plus from this system you can see 11 1 minus M1 minus M2 into H11 equal to because M2 is mixing, so remaining quantity will be 1 minus M1 into H12. That is H12. Already we have calculated M1. So unknown, if you put value of M1, everything are known and you can find out M2. Because already by using this heater we have calculated M1, so you can find out M2 in terms of M1 and put value of M1, you get M2. Same thing apply for energy balance equation for heater number 3. For heater 3 you can write equation M3 into H3 plus from here pump 8 will supply 1 minus M1 minus M2 minus M3 into enthalpy at H9 equal to, when M3 will mix with this quantity, remaining quantity will become 1 minus M1 minus M2 at enthalpy H10. So from this equation you can find out M2, and from earlier equation for heater 1 you can get M1. Putting value of M1 and M2 you can get M3. So this is a way of writing energy and mass balance equation. For reason, but these kind of cycles, these are most important outcome of analysis of reheat and regenerative cycle. How to find out masses taken from for regeneration process from turbine 1 and turbine 2, or any other stage we can take back any quantity. We can take 4 or 5 regenerative process. So this is I think very important that I have discussed. Now let us see how to find out turbine work. WT. You can see how much WT is you can from state 1 to state 2. Full quantity will expand. From state 1 to state 2, full quantity will expand. So H1 minus H2. And from state 2 to state 3. From state 2 to state 3, because M1 is taken back, so remaining quantity will be 1 minus M1 into enthalpy. Enthalpy कितना डिफरेंस होगा? H2 minus H3, and from here again it is reheated. Then from 4 to 5, same quantity will expand. 1 minus M1 into H4 minus H5, and plus from 4 to 5, from 5 to 6 M2 is taken back, so 1 minus M1 minus M2 quantity will remain for expanding from state 5 to 6. So enthalpy difference will be H5 minus H6, and then final state from 6 to 1, this quantity will remain 1 minus M1 minus M2 minus M3. So least quantity that remain for expansion is 1 minus M1 minus M2 minus M3 into enthalpy difference, that is S6 minus S7. So this is a turbine work. Overall turbine work you can find. Same thing for this kind of problems you will find that in questions that turbine work is much higher compared to pump work. So most of the cases when you have to solve pump work neglected, but here you can find out by given data you can find out pump work. So there are 4 Four pump you can see from pump 1 to pump 4 you have to calculate total pump work WP equal to starting from pump 1. Starting from pump 1 how much quantity of steam is flowing? 1 minus M1 minus M2 minus M3 into H9 minus H8. H9 minus H8. And you can see TF diagram also. 1 minus M1 minus M2 minus M3 multiplied by H9 minus, because pumping work is from 8 to 9. So 1 minus M1 minus M2 minus M plus for pump 2. For pump 2 you can see M3 added here. So 1 minus M1 minus M2 into enthalpy difference. H11 minus H10. H11 minus H10. And then pump 3. For pump 3 you can see so 1. Again here M2 is added, so quantity will become 1 minus M1 into, you see pump 3 H3 minus H12, H13 minus H12, and for pump 4 14, pump 4 will be 14 to 15, 14 to 15, 14 to 15. So whole quantity, because M1 is added here, from 14 to 15 full quantity will flow. So that is 1 into H15 minus H14. This is how we can find out pump work. So let us now see how to calculate Q1 heat addition process. How much heat is added in this column? So you can see heat is added in two stages. Heat is added in two stages. One stage is, you can see heat addition takes place in two stages. Stage 1 15 to 1 and stage 2 when reheating occur. Reheating occur from 3 to 4. From 3 to 4 is a reheating process. So in two stage heat addition is taking place. So Q1 equal to H1 minus H15 and plus heat addition, because M1 quantity is taken here, taken back. You see M1 quantity, so remaining quantity will be 1 minus M1. Here 1 minus M1. 1 minus M1 will be reheated from 3 to 4. So 1 minus M1 reheated 3 to 4. So H4 minus H3. This is a heat added. So for finding out turbine efficiency and turbine efficiency and thermal equal to W net upon Q1 equal to WT minus WP upon Q1. All parameters already we have calculated. Putting all parameters in this equation, you can find out thermal efficiency of power plant or turbine or Rankine cycle efficiency of combined reheat and regenerative process. And another thing that sometimes asked to define what is a steam rate. Quantity of steam required in kg per hour to produce 1 kilowatt of 1 kilowatt hour 1 kilowatt of the W net. So steam rate is equal to 3600 upon WT minus WP kg per kilowatt hour. Kg per kilowatt hour. So by already we have calculated W turbine work and pump work. So putting these values in this equation, you can find out this equation. This type of problem, though it is a very complex one, in which because two turbines are there, 3 heaters are there, and 4 pumps are there. But such kind of questions are solved by using Mollier chart. You have to see different values at different stage. By if you know this chart, you can if you draw properly this temperature entropy diagram or enthalpy entropy diagram, you can easily find all values of in Mollier chart. Otherwise, a question process chart will be given and all point enthalpy will be given. You have to find out the mass flow rate. If some enthalpy is missing, then mass flow rate will be given. You have to write equation of energy and mass balance. You can solve. You can find out unknown quantity as enthalpies. Such kind of question only appear in competitive examination, or gate examination, or Indian engineering service examination, atomic research, and all other public sector examinations. So conceptually, this is very interesting. So this reheat and regenerative process is a combined effect. It includes combined feature of the reheat cycle and regenerative cycle. Overall outcome of this cycle is optimum. So optimum efficiency of thermal power plant you can achieve when we use this combined cycle. So thank you very much for watching. In next lecture, we will solve some questions based on this combined cycle, and also you will get practice of how to see molecular chart and how to see values from steam table. Thank you very much for watching my video lecture. I request you please subscribe and like. Thank you very much.